CBT Nugget's Network Plus series, Network Troubleshooting Methodology. Well, this is the 19th nugget of this Network Plus series, and we're pretty far past the halfway point of this series, and I think I'm going to do you a little solid, maybe give you a little bit of a break. This is going to be a nice short nugget. So instead of a CBT nugget, this might be more of a CBT chip or a gold flake or something like that. But what we're going to do here is we're just going to break down a 9-step network troubleshooting methodology. And we've already looked at some of the tools you're going to use, and we'll talk more about that later on in this nugget series. But you need to have a process. And troubleshooting is really an art and a science. You get better at it the more you do it. Experience is always going to help you become a better shooter of trouble. However, it does help to have a troubleshooting methodology. I'll add to these 9 steps a couple of flow charts also that Microsoft uses to teach network troubleshooting that might help you as well. So let's go ahead and take a look at these 9 steps. I'll just break them down for you real quick. We're going to cover these. We're going to look at step 1, which is information gathering. Step 2, which is identifying the areas of the network that are actually affected by the problem. Find out if anything has changed in the network. Establish probable cause. Sounds like a criminal investigation, and you know what? Sometimes it may be a criminal act that causes you to troubleshoot. We'll determine if you need to escalate this up to a higher authority in the organization. Create an action plan and a possible solution, and then identify any potential effects. Implement and test your solution. Identify the results, analyze the effects, and finally, document the entire process and document your solution for yourself and your posterity. All right, let's take a look at these one at a time. I really like those Law and Order shows, especially the Law and Order Criminal Intent. And, you know, this process of troubleshooting your network is a lot like the process of handling a security incident. As a matter of fact, there's several types of processes that can go on, and regardless of the process, the first step is always going to be the information gathering phase, kind of the reconnaissance, where you go in there like the detective and you're just getting all the information you can as quickly as possible. So you're going to go with this network issue, and most likely you're going to find out about this network issue by an end user before you even recognize it. Now, if we're talking about something that's happening on the management or administrative side, then of course you're going to be the user. But regardless, there's somebody who's going to be impacted. So you want to interview that user or any of the affected parties. And you want to find out exactly the nature of the network incident. And one of the first things you're going to try to find out is this happening to a single individual? Okay, is it a single end station being affected, or is an entire group being affected? If you can isolate whether it's an entire VLAN or an entire network segment or just a single user, that right there may lead you higher up the OSI model. You start looking at switches and routers. For example, if you've got multiple users in a VLAN or a subnetwork, and let's say all of them can't access the email server, you're not going to go and start looking at the cables that run from their workstations or their laptops to see if they're plugged in. You're going to immediately move up the OSI model and say, you know what, this can't be all 12 users having physical connectivity issues. So we're going to go move up and start thinking about, well, what do all of those users have in common from a networking perspective? And you would isolate, well, the first thing to look at is the switch or the hub or the patch bay that they're connected to. Now, if it's an application issue, and again, we're going to kind of focus here on networking, but let's say it's a networking application, an application that uses the network, their web browser, their email client, whatever. Try to, if you can, for the sake of time, if that user can do a print screen on their keyboard or an alt print screen and then email you some screenshots so you can see the error messages they're getting, or that they can show you what's changed about their system. Maybe you can walk them through on the phone certain areas and they can make screenshots of it, or you could use remote desktop protocol or terminal services to actually take over remote control of their system and look at it that way. I used to work for a big contract for IBM and State Farm, and when we were troubleshooting client issues at the insurance agent's office, many times I'd have to go up to the headquarters in Bloomington, Illinois, and I have to escalate this to a level 2 or level 3 technician, and they'd have to go do an RDP and take control of the system. So, and I've done that myself as a network operator and a network engineer. And of course, the last thing you want to have to do is go and actually, hands-on. Kind of lost my words there for a second. So, the last thing you want to do from the sake of time, because you're going to be so busy as a network operator or technician, is have to, march yourself down to their end station if it's a large organization and do hands-on. But that may be, what you have to do to gather the information properly. If you're dealing with somebody whose knowledge expertise is, a lot lower than yours, then the hands-on information gathering may be your only option. And then, of course, you want to document all the relevant information. And this is a lot like, those detectives from Law and Order going and just getting all the information they can. Okay? Is it a logon issue? Can the user not log on? Can multiple users not log on? Is this a resource access issue? And what resources can they not access? Network printers, particular servers, or is it files on those servers or shared folders on those servers? Again, it may be a single incident of a user. Maybe they're having slow response. Maybe it's taking a long time to download their email, or their web browsing is slow, or they've got problems with their wireless network, or their IP phone is having delay or jitter. Is there something that's changed about their configuration? Are there icons missing on their desktop? Is their data missing or corrupt? Has there been a misconfiguration? And again, you want to isolate also. You want to nail down in the information gathering, when this happened. Can you backtrack and find a particular point in time? If this was happening, if everything was working great on Friday afternoon at 5 o'clock and it's first thing Monday morning, then obviously something happened over the weekend. So the when and the where are two big questions. So information gathering, obvious first step. Step 2 of our troubleshooting process is to identify affected areas of your network. Now again, this means having good mapping tools. Are you using packet sniffers like Wireshark, for example? Have you created good topologies, physical and logical topologies using different diagrams like we looked at earlier in this Nugget series, schematics of your network? Unless you understand your network topology, physical and logical, you won't be able to identify the affected areas very well. So you need to be able to use tools like ping, network monitoring tools, the event viewer that we looked at in the previous nugget. There's also networking tools. For example, Windows has a tool called NetShell or NetSH. So there's command line utilities that have a number of network related settings in it, and they can be useful for looking at DHCP, WINS, other diagnostics information, IP configuration, remote access and routing, and remote procedure calls. Also, if you're using some type of policy, security policy or group policy in your organization to affect a lot of users, then you want to understand how the policy is implemented as well. So use those tools to rapidly identify the affected areas of a network. Again, you want to have good documentation. And this means you want to have your IP hierarchy mapped out and documented. And again, if you're using good variable length subnet masking and you're aggregating your routes onto higher level routers, if you do have problems with, let's say, network interface cards on end stations or on low level switches or routers, it's not going to affect your entire routing domain. And so that by using aggregate IP addresses to represent a bunch of networks, you can create what are called problem domains or trouble domains. And so you can quickly go to that trouble domain. Know your topologies. I already kind of mentioned that. You also want to know your users and the applications that they're using. You want to know what protocols and services and applications they're using. You want to know which areas of the organization are using certain kinds of applications. And what will help you out in this identification process, this second step, is to actually try to design a modular network at the outset. So you would have, the core layers, you would have the access layers, the distribution layers, you'd have a network management module, you'd have the remote access module, the WAN module, the VPN module. So if you design it from a modular standpoint, you can also attack and troubleshoot from a modular standpoint. You can divide and conquer. You also want to make sure that if you have wide area network connectivity to remote branch offices, remote offices and branch offices, it could help you with your troubleshooting to train remote operators, remote network operators in troubleshooting. Even if they aren't a full-blown network engineer, at least give them some training so they can help you in those branch offices to do some of this troubleshooting so you aren't alone in the process. And by the way, in the process, don't be afraid to ask somebody, a coworker who may have maybe greater knowledge than you do. You got to swallow your pride. Remember, the goal here is to fix the problem as soon as possible for the sake of the organization. And again, before you begin any process, you want to make sure that you have good backups of systems, spare parts, failover between all of your networking devices, and techniques for rolling back. If you make any change to the configuration, you want to have the state configuration backed up so you can roll back to that state if the problem is not solved with your troubleshooting solution. Okay, for step 2 and step 3 here, determining the state changes, I'm going to use a couple of famous diagrams courtesy of Microsoft. This first one's going to talk about kind of a flow chart, a mental troubleshooting flow chart for the local area network, and then I'll show you one for a wide area network. So let's use this as our scenario. The user can't log on, okay? So you're notified by the user via email, over the telephone, somehow they cannot log on. So first of all, you want to make sure that you've gone through the standard network troubleshooting, which means knowing the OSI model, okay? You know that if the user is on their system and their system's up and running and they are not able to get their credentials passed from their system to, in this situation would be an Active Directory server, then you want to figure out, first of all, is this a single user issue or is it a widespread issue? That's one of the first questions you're going to ask because it's totally going to affect your troubleshooting method. If it's a single user, then you're going to go through the standard networking troubleshooting tools, the ping tools, look at the event logs, maybe use remote desktop protocol to access that particular system's operating system and configuration. Because if the other users can log on, you want to isolate this down to an end user client issue. What if it's a widespread issue? Then you're going to start looking at the services. You're going to go to the system logs on your servers. In this case, this is being a Microsoft, we're talking about the Windows servers. So you would use tools that look at the trust relationships between the servers, or authentication. For example, if they're using some type of authentication method, tools to troubleshoot the domain controller, standard networking troubleshooting tools. For those domain controllers that store the directory database. Is it a domain name service issue, DNS issue, not being resolved by a DNS server? If you're using Kerberos authentication, then obviously that would be one of the things you want to look at. And then, of course, you can solve the problem from there. So there's a lot of techniques and tools for determining and isolating the problem and determining changes in the state. But again, one of the first things you're going to do is go, is this a single user or a widespread user solution? And then use your tools and your logs, your mapping tools, your monitoring tools. So let's say now a user can't log on in a wide area network, okay? Then again, same thing. Is it a one user solution? If it's a one-user solution, go look at the logs on that user system. If it's widespread, then you're going to go to the system that those remote users connect to. In a Windows environment, it's a Windows 2000, 2003 routing and remote access server. In your small to medium-sized business, it may be a router or a multi-layer switch or a firewall or adaptive security appliance. And then you go to that system and you look at the logs, you use standard network troubleshooting tools, you look at event logs, you look at application logs for the different services that are being used. Maybe you're using a AAA server, a access control server for Windows. Look at the logs on that AAA server. Once you've followed step 1, 2, and 3, you're now ready to act. So you figured out what your problem is. A user can't log on. You've got multiple users with slow service. You have users who are having sessions, TCP sessions, being dropped. Maybe you have a total outage. Maybe it's a security vulnerability. Bottom line is your next step is establish probable cause. It could be a cabling problem. It could be connectivity between an access layer switch and a multi-layer switch. It could be something in the server room or the wiring closet. It could be a denial of service attack on a system, on a router, on a multi-layer switch, on a server. It could be a software issue. Maybe the user misconfigured it. Maybe they have added, this is add, maybe they've recently added some type of application. One of the first things you're going to ask anybody who's involved in the incident is, what is the last thing you did that was a change to your system? And if they'll admit that they did something, can they duplicate to you verbally what they did? If not verbally, can they show you what they did while you watch them through an RDP session? Maybe it's an IP addressing issue. Maybe you've misconfigured your DHCP solution. So again, just like you're investigating a crime, you want to establish the probable cause of the particular outage or failure or incident. And again, this is really going to become one of those things that the longer you do it and the more you do it, the better you get at it. It's almost kind of like instinctual after a period of years. A lot of organizations out there will use the ITIL, which is the IT Infrastructure Library. It's a systematic process for information technology management in an organization. And one of the domains of the ITIL of the library is incident management. So a lot of organizations are going to have internally in their organization what's called a service desk. Now we've heard of help desks. Help desks are usually for outside customers and for customer service with vendors and customers. But the customers of the service desk, not the help desk, but the customers of the service desk or what we call internal customers or other departments. So many times what will happen is you will issue what's called a trouble ticket, and that trouble ticket will actually be processed through some type of workflow process using email or maybe some other automated process. But the bottom line is this: at some point in time, if you're operating as an individual or just a network operator, maybe you're on a service desk or a help desk, you'll have to decide at some point in time if the solution is beyond your knowledge base and it's now time to escalate this up to a higher level. As I mentioned before, I've done huge contracts for IBM and for State Farm Insurance and other companies as well, and most of these large enterprise organizations have multiple tiers. You've got a tier 1 customer service or a tier 1 service desk, then a level 2, then the highest level is level 3, where you start to get to the actual network engineers, the application developers, those types of things. So determine the need for escalation or involving other people in the process. Next is to create an action plan, and most of the time this action plan is going to be formulated in your head. It's going to be based on experience. It may be based on documentation from previous network engineers or operators or technicians, but you're going to want to document this step-by-step process. Now, you'll most likely document the process after the fact, but along the way you may want to take notes or use a PDA device or some other mechanism to just jot things down as you go, because you're going to want to fully document ultimately when this whole thing is done. And then you want to make sure that you only act on one event at a time. And if you have several problems coming up simultaneously, you're going to have to prioritize. Okay? If the vice president is having problems, for example, opening up some email attachment, but you've got an entire server down that's affecting a whole bunch of applications for a whole bunch of individuals, you have to prioritize and put the vice president on hold, or you need to be able to delegate. So if you're going to act on one thing at a time, you may have to be able to have the power to delegate other issues and other problems to other technicians or operators. And then, once you've identified that action you're going to take, you want to implement one fix at a time, one solution at a time. Do not try to implement 3 or 4 different fixes. Don't throw mud up against the wall, because you want to try one fix. If it doesn't work, you want to try a second fix. So you're going to back up first, roll back second. What do I mean by that? Well, you want to have a backup of the data, of the system and the configuration files, of the application information. Make sure you have a recent backup before you implement the fix, and then have some way to roll back to a system state before you attempted the troubleshooting solution. And then, of course, don't panic. And if you can, get help. Okay, don't be afraid. Don't have too much pride. Don't be afraid to go ask a coworker for help or for his or her advice. Never panic, but create an action plan and be willing to follow through with it. Number 7 is to implement and test the solution. I don't have any bullet points here, but what I am going to focus on is the testing aspect of this. If your fix or if your solution to the problem involves some type of major change or fundamental modification to the network design or the network infrastructure, you're going to want to go ahead and test that solution in some type of prototypical environment first. So if you can, you want to have an exact mirror. The best case scenario is to have an exact mirror of your network topology. Okay, but if you can't, try to create a subset or a subset of that network infrastructure, the topology, and then you can test out that solution. For example, your solution may involve applying some type of service pack or some type of operating system upgrade to a router or a multi-layer switch or some network appliance, or going to a new version of a productivity application. So if you can, you'll want to test that in a pilot testing environment first before you implement a drastic solution like that. Next, you're going to analyze the results, and the results may be favorable, they may not be favorable. So you want to have an iterative process, and that's why earlier I showed you just an example of a Microsoft LAN flowchart and a Microsoft WAN flowchart. Now, those flowcharts are vendor specific, but they're just examples of why you want to have an iterative process. In other words, you want to be able to go back to the drawing board or go back to a different phase of the process until you get the right solution. So part of the analysis is knowing what phase to go back to. If you think you did enough information gathering and you got all the facts, don't go back and start information gathering. The iterative process may involve escalation to a level 2 or a level 3 technician. Consider using an audio recorder, a handheld audio recording device, and actually record the process, your thought process, record the actions you're taking, like a reporter would do, or a detective. Okay? Don't be afraid to use that as a tool to record your mental notes. Don't be afraid also to be able to share your results with a community of people online. Use working groups and bulletin boards and networking communities. You can often find answers there very quickly. Many network professionals go up and use working groups or community groups up on the internet to solve our problems. Then make sure that you implement controls that are going to mitigate against further incidents. In other words, once you troubleshoot the problem, if there is an ongoing issue that's going to cause that problem to recur again, you want to put into place some change configuration management to make sure that you're mitigating against that so it doesn't keep happening over and over and over again. This is one of the biggest things I see happen a lot in networking professionals. They get the problem solved and they want to move on. They've gotten the thrill of conquering the problem, but the boring part is step 9, documentation, and then often going through the financial and political process of putting in place some type of mitigation, some type of solution. And then again, be prepared for unexpected risk. What I mean by this is oftentimes things that you do to fix a problem are going to have unexpected consequences on other users, other systems, other applications, and it's just bound to happen sooner or later. So expect the unexpected. Analyze your results. One of the great things about using a PDA device or a BlackBerry or even doing audio recording of the process is it'll make it easier for you at the end of the process to fully document hopefully your solution and really the entire step-by-step process that you went through, even the mistakes you made, even the unexpected consequences. You can obviously use a web-based tool. There's a wide variety of web-based tools. Any network operating system, a lot of third-party vendors are going to provide tools that offer ways to create reports and summaries. They'll use XML formats. You can basically present these in a wide variety of different outputs. You can use SharePoint. SharePoint has its document libraries with a lot of different features attached to that as well. Implement those logging servers and you can generate reports from those logs. You have all types of filtering tools to filter out information because you will be documenting, you will be generating reports and summaries, often to finish up the trouble ticket, or if it's a service desk issue, there's going to be some type of resolution process. So the incident management or configuration management is going to want to know how it got resolved. So you will be held responsible for delivering documentation on the solution and documentation on the process and generating summaries and reports. Obviously the goal here, and if we're talking about ITIL, which we're not, but ITIL is a good example. What is the goal of ITIL? It's constant improvement, and that's the goal of these 9 steps of troubleshooting, constant improvement. Let's review these 9 steps and we'll finish up this nugget. This is definitely one of those things you're going to want to memorize, all 9 steps of these in order for your CompT and Network Plus exam. So, in this nugget on network troubleshooting methodology, we looked at 9 steps. Step 1, information gathering. Identify the symptoms and the problems. Step 2, identify the affected areas of the network. Step 3, determine if anything has changed. Hardware, software, data, systems. Step 4, establish probable cause. Step 5, determine if any escalation is necessary using a help desk or service desk or trouble ticket process. Step 6, create an action plan and a solution that identifies potential effects. And a solution that identifies potential effects of that solution, positive and negative. Step 7, implement and, if possible, test the solution. Step 8, identify the results and the effects of the solution. In other words, analyze the solution and the results. And finally, step 9, document the solution and the entire process. Well, I hope this CBT Nugget has been informative for you. I want to thank you for viewing. See you later.